All right, so 1.5 equation. So here we're going to use properties of equalities. So we've been doing expressions up to this point. Now we're going to actually solve this stuff with equations. So we're going to have A equal to B. So we can add something to both sides. So if I add 5 to both sides of the equation, that's okay. And I can cancel stuff from both sides. So if A equal to C, this arrow means what we call if and only if. That's what it means. It means you can go from this side to this side or this side to this side. So to solve an equation, I can add c to both sides if that helps it, or I can cancel c from both sides, so I can remove it. Here, if I want to solve an equation, I can multiply c to both sides, or I can remove c from both sides. So you can go either direction. So that's where that comes from. Here, a linear equation has the following form. And so we're going to just solve linear equations for the first page. Or for the first two, just to get you warmed up. So in order to solve this, the first thing I like to do is move all the x's to one side and all the so I'll do this one step at a time. I'll do a little bit faster over here. So here I'm going to move both sides. So minus 2x to both of this. So on each side of these equation, I'm adding negative 2x. Negative 2x here would be, so here I'd get an x minus 3 equals 0. So we just have the 2. Okay, and then here I'm going to add 3 to both sides. And often you just write it below the term which you're going to be manipulating. So I'm going to add a 3 here and add a 3 here. So here I have an x. So negative 3 plus 3 is 0. This will be 5. And that's how we get our solution of 5. Now, how do you do this in practice? What we usually do in practice is here I'm going to move the x's over here. So I write the x minus 3, and then I go ahead and move the 4 over. So I add 4 to both sides. Okay. So doing this, negative 7x plus 3 is 4x. Um, plus the 4 is 0 equals 0x plus 4, which would be 12. And then we're just going to divide both sides by 4. Um, Remember, dividing both sides by 4 is the same thing as multiplying by a fourth. So I could write it this way. No one really writes it this way. We all just write it this way. Divide by 4. Get rid of your coefficient. And so we have x is equal to 3. Okay. All right. So for you engineers, you're not going to be doing you're going to be doing stuff that looks like this. And so, does anyone know what this equation is? Or does anyone know what this equation is? Does anyone know what equation A or B are? I don't. Okay. These are both real world equations. See, I see length and width. Yes, one looks like the area of something. Yes, you are very correct. So, this is an area of something. So, this is the surface area of a box. I have 2 times the length. So we'll call this L, we'll call this W, we'll call this H. So 2 times LW would be the top and the bottom of the box. WH would be the 2 sides of the box, and this would be the other 2 sides of the box. Okay, so this is the area, the surface area of a box. This is the gravitational force. You'll see this one in your physics class eventually. Well, the force of gravity is equal to the gravitational constant, the mass of the larger object, usually the Earth, the mass of the smaller object, and the radius between them. And so we have this. You sometimes use this for astronomical bodies. The problem is that the gravitational force between two people walking down the street is so negligible no one feels it, right? um, but it does exist. And so here we want to solve this for little m. And so if I'm going to solve this for little m, I want to solve for this term. And so what I'm going to do is I'm going to move everything over. And to do that, I'm going to do this slowly in steps. So I'm going to get rid of my fraction here. So I'm going to multiply both sides by r squared. So I'm going to multiply both sides by r squared. Actually, let me do this on on so here I'm going to multiply by r squared and I squared. And so this is something I'm allowed to do. So I can cross this off. And then I'm going to divide by, so I have r squared f equals g m n. So I'm going to divide by g and m, g and m. So I have little m. So I have r squared f over g m is equal to the little m. And so this is something you're going to do a lot in your physics classes, and I assume in your engineering classes, you're going to want to solve for one of them knowing the others. Here, if I want to solve for w, how do I do this? Well, let's move everything that doesn't have a w to one side. So I'm going to minus out the 2LH from both sides. Let me use this for my L. So I have A minus 2LH is equal to 2LW plus 2WH. Now, the next thing I want to do is I want to factor out the W. I'll just use a ditto mark. W is equal to 2L plus 2H. Let me not use the ditto mark. Woo, I'm on the wrong layer. That's fine. A minus 2LH. Come on the right layer. Then I'm just going to divide that from both sides. And most of the time, you actually don't write out the division. You just perform it like this. And all your professors should be able to follow what you're doing when you divide it out. And so here, the width is equal to area minus 2LH divided by 2L plus 2H. Okay, I'll leave that for you guys to copy. All right, let's do the next one. Boop. All right, so quadratic equation. So if we have a quadratic equation, this is what a quadratic equation. So we're going to use the zero property. Please be very careful when doing this. So if you can factor use the zero property, that means that if a times b equal to 0, that means either a was 0 or b was 0. And in math, it means both, right? So in math, when we say a is 0 or b is 0, that means there is a possibility that both a and b is 0, and that's perfectly valid. So in English, or means you pick one at the exclusion of the other, right? So if I walk up to an ice cream stand, right, and it says you want vanilla or chocolate, you pick one, right? But as a mathematician, I just go yes and grab them both and run away, right? I'll do that at the end, okay? I'll do that at the end. Just remind me at the end. So make sure, so this mean can be both. Make sure this is a 0. You would not believe how many times I've seen x plus 2 or x plus 3 is equal to 5. That means x plus 2 is equal to 5, or x plus 3 is equal to 5. This is not allowed. This is so not allowed. You can't do this. This has to be a 0. Okay? So do not do that. Do not do anything that looks like that remotely. So, all right, so let's use this. So here, that means that either 3x plus 3 was equal to 0, or x plus 2 was equal to 0. Let me usually put a little or right here. So, this means that x is equal to -1, or x was equal to -2, And we used to just write this instead of writing the or. We just use x equals -1 comma -2. That means it could be, and when we write it this way, that means x is -1 or x is -2 or x could be both, right? And so the solutions are actually both of these. Both of these will solve this. If I have x equal to -1, this equals to 0, and we're done. If x is equal to -2, this equals to 0, and we're done. And let's go ahead and do this one. So the other way we can do this, if we take the square root of both sides, which is a valid operation, you can take the square root of both sides, right? So if I take the square root of both sides, it's either this, then x equals this, and this, and so um, this should be an or, because the mathematical or uh, is better. So here we have x equals square. That means x is equal to the square root of 7, or x is equal to minus the square root of 7. Usually what we write is x is equal to plus minus square root of 7. So this plus minus symbol means both x square root 7 and negative square root 7. Very rarely you'll see this symbol. This is the minus plus symbol, and you only see this symbol if you see this symbol. So here, if I was writing out some equation, x equals plus minus square root of 5, then minus plus square root 6. That means if it was plus square root 5, this would be the negative. And so you only see this symbol in conjunction with that. It doesn't come up that often, but when you do see it, I don't want you to be confused. I want you to at least heard about it, okay? So that's the minus plus symbol. Okay, so that's not for this class, but it's just something for you to see. All right, so here, so to solve this, we're going to have to move everything to one side. And that's usually what you do for quadratic equations. You move everything to one side and have it equal to 0. And so most of the time when you're solving a quadratic equation, you move everything to one side, set it equal to 0, and solve. So here, if I do this, I'll get x minus 8, x plus 8, x minus 3. It's like, so that gives me this, and then here I'll just say x is equal to, and then you just flip the sign here. So that means either x plus 8 was 0, so that'd be x equal to -8. And then here it'll be x minus 3 was 0, that means x was 3. Okay, and so once you factor it, it's just the opposite of the sign you see here. Now here, now I can use this rule, since I have a square here, is I can have x minus 3 equal to the square root of 3, or x minus 3 equal to minus the square root of 3. So here I can actually perform the square root operation here. Another way of doing this is you can expand this out, move the 3 over, and then solve using the quadratic equation, but this just tends to be faster. And so once we do that, this becomes x equal to 3 plus square root 3, or x is equal to 3 minus square root 3. Or I can just write it all as 1. X is equal to 3 plus minus square root 3. Okay. And I'll leave that there for a second. So for these first 2 pages, I suspect most of you are fairly comfortable doing it. So we're just knocking off a little bit of the rest if you had any. These next 2 pages, I assume a little bit less so. And so let's do the next 2 pages. All right, completing the square. So you can complete the square. Now, this is a terrible way to solve an equation, in my opinion, but it's a wonderful method for learning about the graph of a function. And so we're going to go ahead and do it. I mean, sometimes it's a good way, but it's less often useful. So we're going to complete the square, and I'm going to show you step by step how to complete a square. Most students forget how to do this. So let's do it. So here, you can complete this square by adding. So the first thing you want to do is exactly what you didn't do last time, which is, remember how I said move everything in here? If you wanted to solve this, just type it into a computer or the quadratic equation. But I'm going to show you how to complete a square. So we're going to move this back over. So I'm moving this back over. Why? Because I want dx squared plus bx on one side and everything else on the other. Then I'm going to add b squared over 2. So b in this case is -2. So b minus, or -8, sorry. -8 divided by 2, and then I'm going to square it. Because b here is -8. So b squared over 2 would be -8 over 2, which would be -4. -4 squared is 16. So we're going to add 16 to both sides. So add 16, add 16. So this gives me x minus plus 16 equals -13 plus this is just 3. This, because we completed the square, is equal to this. So -8 over 2, so this be plus 4 squared. You can also factor it to get to this. 3. And then I can solve it from here. If I wanted to solve from here, it's just exactly like we did last time. This will be x minus 4 equals plus minus the square root of 3, or x equals 4 plus or minus the square root of 3. So the big thing, the big takeaway I want away from here is how to complete the square. You get it to look like this, and then you move everything over. Okay. Here, we want x squared plus bx, and so the first thing we want to do is I want to get rid of this coefficient. So I'm going to pull out a 3 everywhere. So I have x minus x squared minus 4x plus 2. I will set that equal to 0. Notice if I multiply both sides by a third or divide by 3, same thing, right? 0 times anything is still 0, so you can just kind of throw it away. And so here I just have x squared minus 4x plus 2 is equal to 0. We're going to move over that 2. Minus 2. All right, so now let's complete the square. So here, b is equal to 4. So b squared, so 2 divided by 4 divided by 2 is 2. 2 squared is 4. So we're going to add 4 to both sides. And so we have x squared minus 4x plus 4 equals 2, or x plus 2. Oops, x minus 2 squared is equal to 2. Means x is equal to, oops, let me not skip that step. Square root 2, which means this symbol right here means implies. It's basically a way of writing two equations on the same line instead of going down. 2 plus or minus 2. Okay. We will be doing completing the square later when we're doing graphing stuff to help you put graphs in the right place and sort of thing. Yeah. All right, so how do you usually solve this quadratic formula? You just chuck it through the formula. And so you should have this memorized. You're just going to use it enough. enough time in your life on equations and stuff, you're gonna memorize and then you're gonna become an engineer and not care. Just the truth of it. Just you see something, type it in a computer. Um, Apparently, people now learn it to like pop goes the weasel. I never learned it to pop goes the weasel, but apparently you guys do. At least that's what I've heard recently. Um, did anyone learn this formula by pop goes the weasel? Thank you for reminding me. I did. Okay. Unfortunately. Fair enough. Yeah, flashbacks. All of a sudden, we all have PTSD. No. All right. So, the nice thing about this is you don't have to factor, you don't have to do anything. As long as this is zero, as long as you have a zero on this side, you just crunch through it. So, here we'll just have negative b in this case. So, it'd be positive 5 plus or minus the square root of b squared. So, it'd be 25 minus 4a, which in this case is 2, c, which in this case is 1, divided by 2a, which is this. And then if we just simplify this out, we get 5 plus or minus the square root of 25 minus 8 all over 4. And yeah, we can do one more step. So we'll have this is equal to 5 plus or minus the square root of 17 over 4. Same thing here. Just plug it in as you see it. So negative b plus or minus the square root of b squared. So it'll be 144. Yeah. Minus 4 times a, which is a would be 4. And then c would be 9 all over 2a, which is 4. So here we have x equal to minus 12 plus or minus the square root of 144 minus 144. Yes. So this all ends up being 0 over 8. And so here we just have 3/2. So that's the only answer. So in fact, this answer, so for quadratics, the fundamental theorem of algebra is saying a polynomial of n degree will have n roots. We'll get into that a little later. And so here we have two different answers. So for quadratic, we'll have two different. For cubic, you should have three different answers. Here we only get one answer. What happens is this answer is kind of there twice. If that'll make more sense when we deal with it. Okay, so I'll leave this up for a second. We'll get to our last page. All right. Let's do the last page. This last page is what I call the quote unquote page of nightmares. It's all the really bad equations you might see. So there's a bunch of other equations. They bunch have their own little caveats. Fractional equations, you must check the ants. Irrational, you have to check it. Um, this should be rational. This should be radical. So rational equations, you have to check answers to main. Radical or stuff like this, you have to check if it works at all. Absolute values, you have to solve for both positive and negative. Other can be false if you have to check your answers. So let me kind of go over these real quick. These won't really be on the exam, but I do want you to see them, and this is where your book does it. Trying to fit this all into 2 pages is a nightmare. Yeah, trying to write all this out is Yeah, so let's go for it. So here, in order to solve this, what I usually do is I usually clear the fractions, right? And so if I'm just solving this, I'm going to multiply everything by the least common multiple. The least common multiple. So the least common multiple here is x, and x for the denominator is x. So I'm just going to multiply both sides of the equation by that. So x plus 2. And the reason I do this, it clears out fractions. I do not, or the rational expression. So here, 3x times x plus 2 plus x is just 3 times x plus 2. 5 over plus 5. If I multiply by this, notice here the x plus 2 and x plus 2 cancel, so I'm just left with 5x. And then I'll have 2 times x plus 2 times x. All right, and then we'll go ahead and simplify this. So this will be 3x plus 2 plus 5x equals 2x squared plus 4x. So just multiplying across. And then here we try to get everything to one side. I'm going to move everything this way just for my own sanity. So we'll move the 3x, so 3 and 5x, so this is 8x minus 8x, so this would be 2x squared. 4x minus 8x would give us negative 4x, and then if I move the 2 over, it would be minus 2. Oops, that's not a 2, is it? This is a 6. So we'll move over the 6. Okay, and then here we have a 2 everywhere, so I can just throw away the 2. So if you have a common factor here, you can just throw it away. Because basically, if I divide both sides by 2, I will get what I desire. I factor this factors into x minus 3, x plus 1, and I get 0, and then that means x is equal to positive 3 or minus 1. Okay, so when you see a rational expression, these are whole sections in other books, just clear it out. Just clear that out. All right, let's do this one. So here, if I have a radical expression, how do I do this? What you usually do is you get it all to one side. So you move everything to one side, and then you square both sides to get rid of the radical. So I have 2x minus 1 squared equals 2 minus x. So here I'm squaring both sides. We're going the other direction. So 2x minus 1 squared is 4x squared minus 4x plus 1. Yeah, if you perform that operation, you get 2 minus x. Move everything to one side. We'll get 4x squared minus 3x minus 1 equal to 0. You factor this, which is rough to factor. It's actually not that bad since this is 1. So we'll assume it's 4x and an x. That means this one's the plus 1, this one's the minus 1. Yeah. Equal to 0. I'm glad you guys are correcting me in chat because that means you're paying attention. It also means I made a mistake. All right, so here we get two solutions, right? So this solution will give me x is equal to a negative fourth. This solution gives me x equal to 1. Well, you have to test these, right? You have to test. So if you have a radical equation, you have to test them. So let's test the 1. So let's test the 1 because that's easier. So let's test the 1. So we have 2 equals, so 2 times 1, put it in here. 1 is equal to 1 minus square root of 2 minus 1. I always plug in parentheses for reasons. So 2 equals 1 minus the square root of 1 minus the square root of 1, which is 0. This doesn't work. So this isn't a solution, right? This one doesn't count. This is bad. It's a bad solution. Let's test the other one. I have 2 times a minus a fourth equals 1 minus the square root of 2 minus a fourth. So minus a fourth. So this equals, hold on, let's just do this. So this equals negative a half. That's good, right? That's equal to 1 minus the square root of 9 fourths. So if I have 2 and I add a fourth to it, I get 9 fourths. So this minus a half equals 1 minus, this becomes 3 halves. If you pull it out, and that is true. And so here is the only answer. This one doesn't count. Okay. So this one right here is a bad solution. So when you have radical equations, you have to test your solutions. It's just what it is. You can zoom out a little bit. Here, the book wants you just to say, hey, I can factor it this way, x squared. And then I can just factor this is x minus 2, x minus 3 equal to 0. And that means either x squared, x squared minus 2 equal to 0, or x squared minus 3 equal to 0. Sorry, I wanted to let me zoom back in so I'm not writing so terribly. That means x squared equals to 2, or x squared equals to 3. That means x equals plus or minus the square root of 2 plus the plus or minus the square root of 3. So here you can solve other stuff using weird polynomials like this. And you can use the same thing to solve this one, right? So here I have x to the 1/6, because remember, x to the 1/6 squared is equal to x to the third. So here you can use what you've learned in order to solve this. And then you can just factor this normally, which would be -1 and +2. Yeah, equal to 0. You rewrite this as x to the 6th power, or the 1/6 power is equal to 1. X to the 1/6 power is equal to 2. So what we're going to do, we're going to raise both things to the power of 6. So this is x equal to 1. 2 raised to the power of 6 would be 64. We need to check both these answers. If we plug in 1, I'll get 1 plus 1 minus 2. Oops, this is supposed to equal to 0. Hi. My equations don't equal equations right now. I'll have to fix that. Sorry about that. So here, 1 plus 1 minus 2 equals 0. Yeah, that's good, right? The 64 doesn't work. I'll just tell you right now, it doesn't work. Let's do our last one real quick. And our last one real quick is here. If I want to solve this, I can remove my absolute value by solving for the positive version, or 3x minus 4 is equal to the negative version. And the negative version here is I have a little -5. I solve this out, I'll get 3x equals to 9, x equals to 3. So move that over. Here I'll get 3x equal to -1, or x equal to -3. And so here our answers are -1/3. Hi, my thing is getting crunchy. And 3. And that's it. So these are just a bunch of equations. Let me zoom out so you guys can. So that's it. So these are just a bunch of ways to solve a different sort of equation using the quadratic techniques. So here